Hi everyone. So today we're going to start a new topic in physics. This is going to be the last topic in Unit 2 on forces. And this topic is the force of friction. So I'm going to split this up into a few lessons actually, starting with the key concepts of friction, and then after that we'll look at solving some different types of problems. Okay, the first thing to know about friction is that there's two types. There's static friction and there's kinetic friction. So the word static actually comes from the word stationary, or it's related to the word stationary, meaning not moving. So there's going to be friction between objects, and they might not move. Okay, so maybe the friction is so strong that it does not allow the objects to move. Whereas kinetic friction, so the word kinetic comes from a Greek word that relates to the word motion. So kinetic friction is friction that occurs when the objects are sliding against each other. So a simple example is just me applying a force onto a textbook here. So I can push on the book a little bit. So right now my finger is applying a small force on this textbook, not a lot, but maybe 1 Newton or 2 Newtons of force. I'm going to push a little bit harder now, and it's still not moving. Okay, so why is the book not moving? Well, because there's friction. Okay, there's friction from the tabletop resisting the motion. And right now this friction is called static friction because while I'm trying to move it, it's not actually moving. However, if I push hard enough, then it does move. Okay, when I push hard enough, then it does move. And as it's moving, there's still friction. There's still friction resisting that sliding. However, that friction has a different name now. It's going to be called kinetic friction because they are actually sliding on each other. And it is very important to distinguish between the two because static friction can actually be a range of numbers. Okay, starting from 0 newtons all the way up to some maximum amount. So as I was pushing on that textbook, I was increasing my force slightly. Okay, so from 1 Newton to 2 Newtons to 3 Newtons, and the book stayed still. So since the book stayed still, that means the forces are balanced. That means that the force of static friction was always matching whatever my applied force was. If I applied 1 Newton, then static friction would be 1 Newton. If I applied 2 Newtons, then static friction would be 2 Newtons. If I applied 10 Newtons and it still didn't move, then static friction would be 10 Newtons. Okay, until I get it large enough so that it does move. And once it does move, the friction changes to kinetic, and it's going to be a fixed value. It's going to be a fixed value. So for example, let's say I push the book and it's sliding, and kinetic friction might be 8 newtons, for example, while the book is sliding. Now, if I push the book harder and it continues sliding, kinetic friction is still going to be 8 newtons. It's going to be the same number, no matter how hard I push, as long as it's moving. Okay, so that's a big difference between static and kinetic friction. Static friction just matches whatever force it needs to be to keep it at rest. But once it's overcome static friction, it turns into kinetic, and the value is going to stay at the same value until it stops sliding. All right, so those are two types of friction. I will show you that another time, actually, with this PhET simulation. All right, so you've seen this before. Before I set the friction to none, I think, when we were talking about something earlier in the unit. But now I want to show you what happens when there is friction. So I'm going to do the same thing, basically, as my hand pushing a textbook. But now with this simulation, you're going to be able to see some numbers. So this person's going to push on this box, and the amount of force he pushes with is right here. Right now it's 0 newtons. And I'm going to increase it. So I've increased it to 10 newtons. And you'll see that the box has not moved yet. It's still at rest. And then if you look up here, you'll see the numbers for applied force, 10 newtons. And you'll see the number for friction force, which right now, since it's not moving, it has to match the applied force. It's 10 newtons. And I can make the person push harder. So I'll put it to 20 now. And you'll see that it's still not moving. So now the applied force is 20 newtons and the force of friction is 20 newtons. So it's what's important to understand right now that while it says friction force, you have to know that it's actually static friction right now. Static friction right now. And I'll keep increasing the force, 30, 40, and you can see the numbers go up on both sides. It's always, the static friction's always just matching the applied force to keep it at rest. And it's going to keep doing that until this person pushes hard enough. And I already played around with this before this video, and I think the box will start moving when the applied force gets to 60 newtons. Okay, so when this gets up to 60, the box will start moving, and the friction will turn into kinetic friction. But I want you to really pay attention to this number here for the frictional force. Watch what happens to this number when I get to 60 and beyond. So you might have noticed a big drop right there. Once my applied force reached 60, the box started moving. So now the static friction has become kinetic friction, but you'll notice that the number of newtons dropped. It went from 59 and immediately dropped down to 44. Okay, and that's something I'll talk about a bit later on. But I'll keep increasing the applied force. Look, my applied force is going up, but the kinetic friction stays at 44. So that's what I was talking about. One big difference between static and kinetic. Static can take on different values. Kinetic only takes on one value. All right, now I'm going to slow this way down. I'll remove the applied force. I'll drop down the applied force. Okay, the applied force is a lot lower than the kinetic friction. Now, the kinetic friction is still 44 newtons. Like, it's still moving, so it's still kinetic. And the kinetic value doesn't change. It's going to stop soon. Watch what happens when it stops. There. After it's stopped, kinetic friction has now turned back to static friction. And in the case of static friction, the frictional force is matching this applied force. All right, so that's the first major concept about friction. It's to understand the difference between static and kinetic. Secondly, friction has a formula. Okay, so the force of gravity had a formula. Last week we did that. Now this week we do the formula for the force of friction. So this is the force of friction. Its magnitude is going to equal to mu. So this symbol here is a Greek letter called mu times the magnitude of the normal force. So mu is called the coefficient of friction. Okay, so you may have heard the word coefficient from math class. Coefficient simply means a number that's multiplied to a variable. So this mu value is just going to be a number that's going to be multiplied by whatever the normal force is. Okay, and just multiplying those two gives you how many newtons friction is. Its value depends on the two surfaces in contact. So some surfaces are slipperier than others. Okay, if you try to walk on ice, so that would be the bottom of your shoe, which is probably made of rubber. trying to slide on ice. That's a lot more slippery than the bottom of your shoe against concrete, for example, like a sidewalk. So the value of the number that gets multiplied to the normal force, it depends on what the two surfaces are that are sliding together. Oops. Now notice what this formula does not depend on. Okay, the force of friction does not depend on surface area. Okay, so you might think that if I try to push this book across the table, that since it's flat against the table, there might be more friction. There might be more friction than if I held it this way, because there's less contact. However, that's actually not true. Okay, that's not the case according to the formula I just showed you. There's no room in this formula for surface area at all. So friction really only depends on three things. It depends on whether it's static or kinetic. So that means whether it's moving or not. It depends on the coefficient of friction. So that means it depends on what the two materials are. And the third thing it depends on is the normal force. Okay, the higher the normal force, the more friction there will be. So for the textbook, if I try to push it, I can push it pretty easily. But if I stack 4 books together and try to push it, it becomes a lot harder. It becomes a lot harder, and that's because the normal force is larger now that there's more mass. Okay, so the normal force affects the amount of friction. And on this last slide here, I show a table. This is from the textbook. This just shows a whole bunch of different values for coefficient of friction. All of these values are determined experimentally. Okay, so people took the time to do experiments to try to determine the value of mu, and they did it for all these different pairs of materials. So the first 4 deal with tires on the road. Okay, rubber is what tires are made of on concrete when it's dry. And you should also know the value for when it's wet. Notice how the values for when it's wet are less than the values for when it's dry. That means when it's raining and the roads are wet, there's going to be less friction. It'll be more slippery. All right. You may also notice that for the ones where there's both static coefficient, so mu s stands for the coefficient of friction in the static case, and mu k stands for the coefficient of friction in the kinetic case. You may notice that the static value is usually higher than the kinetic value anytime that both of them are given. All right, and that's actually why there's a sudden drop with this example. Okay, so the static value is higher, so the static value went all the way up to 59, but as soon as it became kinetic, it dropped down to 44. Okay, so you will find that the static value is usually higher than the kinetic value. All right, so in the next video, I'm going to talk about a couple of examples, and then we'll get you practicing on friction.